learners, welcome once again to Cloud Comprehensive Tutorial, where we offer excellence with utmost simplicity. We try as much as possible to simplify complex facts to very easy form for you to easily understand and work with it better. So this morning we'll be looking at a very important topic titled the geometry of straight lines. We'll be looking at it from the very beginning, keep building to the most complex part, and see how to simplify each step for proper understanding. So we'll be starting with the definition of what a line is. Just like I said, we're starting from the very beginning. We'll be looking at a line, then our major focus, and keep building that way. So just follow me carefully. A line is simply a set of points which extends infinitely in two directions. Lines can be of different types. We have dotted lines, we have curved lines, we have continuous lines, we have dashed lines, so many kind of lines. But the main focus this morning is to see how to dwell on what a straight line is. We actually want to understand the geometry and everything about a straight line. So what then is a straight line? We say a straight line to be a line which is not bent or curved and it extends infinitely from both ends. So take note of these major terms. I use it is not bent or curved and it extends infinitely from both ends. That's what we refer to as a straight line. So a straight line is most times expressed as a linear equation and an equation of first degree, which means the power is not greater than 1. Yes, the power is not greater than 1. So then we want to see the general equation or the mathematical expression of how a straight line looks like. So we have the general form of it, and we also have the slope intercept form, right? The general form of it is what we present to be your ax plus by plus c equals 0, where a, b, and c are constant, while your y equals mx plus c. Your m there is representing your gradient, while your c there is representing your intercept. So follow me. Now, just like I said, your m represents your slope and your c represents your intercept. Now, provided you have a line and you have two arbitrary points, x1, y1 and x2, y2 on a line, and you want to know the specific distance between these 2 points, we use the specific formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So this formula is used to get the exact distance between 2 points on a line. So we have a very clear example here where we are asked to calculate the distance between 2 points. The first point given to us to be minus 1, 4, and the b point to be minus 2, minus 3. So representing our formula well, first thing we want to do is to find what's the change in x2 and x1, right? So all we have to do is the value of x2 there is minus 2 and the value of x1 is minus 1. So working with your signs very carefully, you should have minus 2 plus 1 giving us minus 1. Change in y, y2 minus y1 minus 3 minus 4, which is giving us minus 7. So imputing this in our formula, since we've already gotten the change, is to just take the square of them and add them up. So the square of minus 1 is 1 and the square of 7 is 49, right? So 41 plus 9 is giving us 50. If you take 50, you have root 25 multiplied by root 2, giving you 5 root 2. And if it's in decimal, you're having... Now, progressing forward, we want to look at the midpoint of a line. Just as the word implies, the word middle represents just the midpoint or the distance between just an end to the center, right? So we want to look at the midpoint of a line. How do we get to the midpoint of a line? Now, provided we have two arbitrary lines, or arbitrary points rather, x1, y1 and x2, y2, and you intend to get the midpoint of it, all you have to do is to just sum the x component, divide by 2, sum the y component, divide by 2, just like getting the average of them, right? So a very clear example is given there. We're asked to find the midpoints of the line segment with endpoints 2, 3 and 4, 5. So all we had to do was add that. We are not adding 2 plus 3, right? We're adding the x1 and the y1, which is 2 plus 4. And we're adding that of the y component, which is 3, and that of the other y2, which is 5, right? So 2 plus 4 is giving us 6, 6 divided by 2 is giving us 3, 8 divided by 2 giving us 4. So we have another example here to still find the midpoint of the line segment with endpoints 1, 5 and 3, minus 1. Following the same principle, you'd want to identify or label your x1, y1 and your x2, y2. So summing the both up, we have minus 1, 2 as the midpoint. Now let's talk about the gradient or slope of a line. The gradient or slope of a line is simply the measure of how steep it is. Yes, it's simply the rate of change of rise to that of run. We simply measure how steep a slope is or a graph being plotted is what we refer to as a gradient. Now, the gradient is represented with the letter m, and it's simply the change in the y component or the y values with respect to that of the x. Now, provided you have arbitrary points, I gave a very clear example here. Now, if you take a very close look at the graph we have here, we have the y-axis and we also have the x-axis, right? We have points here, x1, y1. If you're following carefully, when we're talking about distance, just like providing these 2 points being given to you, and you also calculate the distance between 2 points. I'm doing a little review. I said it's the square root of what? X2 minus x1 plus what? That of y2, the difference between y2 and y1. You get your distance between those 2 points. But now we're more concerned with the slope, right? And I say the slope is simply the change in the rise, to that of the run. on the x-axis, right? Now, a slope can be positive, it can be negative, it can be horizontal, it can also even be vertical, depending on the point given to you. Now, just like this slope we have here, it's a positive slope. You can see it's moving from left to right. A negative slope, we move from the y-axis downward. You know that slope is actually a negative slope. So we have so many types of slope. Now, the next thing we want to look at is the degree, the difference, or the angle between these 2 points. To determine the angle between these 2 points, you simply use theta equals tan inverse y over x. That is, you're simply substituting the y value or the y component, and you're substituting the x component respectively where needed. Now let's quickly look at some examples here on that gradient so we can fully understand the concept of gradient and how to solve questions associated with them. We have 2 examples here. The first example says find the gradient of the line passing through points 2, 3 and 4, 5 and the angle of inclination. Now your gradient formula is simply y2 minus y1 over x2 minus x1. But before then, the first thing you want to do is to label your points. x1 to be 2, y1 to be 3, x2 to be 4 and y2 to be 5. Labeling it this way aids you to substitute them quickly and you get your answer. Now substituting y2 5, y1 3, x2 4 and x1 to be 2, you get your gradient to be 1. Now we also asked to find the angle of inclination, and if you've been following, angle of inclination is simply theta equals tan inverse of y over x, and y over x is simply the same thing as your gradient, which is m. So we can simply say theta is tan inverse of the gradient, and the gradient here is 1, so shift tan 1 gives us the angle of inclination between those 2 points to be what? 45 degrees. Let's quickly look at the second example. You might want to pause the video and try this out yourself. Find the gradient and angle of inclination of the line passing through points 0, 1 and 3, 7. So first thing is label your points, always do that. x1, y1, x2, y2. Substituting your values, you get the gradient to be 2, and theta equals tan inverse of m, which is your gradient. So if you do your tan inverse 2, you get the angle of inclination between the 2 points 0, 1 and 3, 7 to be 63.43 degrees respectively. Now let's move further. The next thing we want to look at is the equation of a straight line. The equation of a straight line. The equation of a straight line can be represented in several forms. In the earlier part of this video, I showed you 2 equations of a straight line. Now we have about 4 different types of it. The most basic form is the point slope form, where you have your arbitrary points x1, y1. So this is a point slope form where you have your y minus y1. We're going to be using this a lot, and you expect it to be more conversant with this. In fact, all of them. So when we talk about the slope intercept form, y equals mc, mx plus c, that's when there's an intercept. We also have where the line crosses the origin. Now in this case, there is no intercept, right? Intercept is 0, which is y equals mx plus 0, which is y equals mx. So in that case, we present the equation of a straight line to be y equals mx. Now one major thing about a straight line is it is a linear equation and also an equation of first degree. When you see a square on an equation, you know that that equation cannot be a straight line, right? Now you have a general form. The general form of a straight line is represented to be ax plus by plus c equals 0, where a, b, c are constant, right? So you have these 4 major forms of representing equation of a straight line, and I say the most one we'll be using the most is the point slope form. So do well to write that down on your notebook. Now let's continue. We have some examples here to fully understand how to find the equation of a straight line. Now the first example here we have is to find the equation of a line with gradient 2 and passing through the point -1, 3. Now let's go back and look at our point slope formula. You have y minus y1, which is your point. Your y1 here is where you use the forming equation. Your y1 here is your point, and your m here represents your gradient. Your x1 here is your point. Your x and y are constant, they don't change, right? So you're only giving value of x1 and y1 to substitute, and then you can be able to find the equation of the slope, or the equation of a straight line rather. Now we are told to find the equation of a line with gradient 2 and passing through the point -1, 3. So here we are doing a very simple and direct substitution here. Your m is 2, your x1 and y1 respectively are -1, 3. So substituting your values, y minus 3 equals 2 into bracket x. Remember your x1 is -1, so you want to put that in the bracket. 2 into x minus -1, giving you 2 into x plus 1. Solving your equation, you have y minus 3 to be equal to 2x plus 2. Collecting like terms, you have y to be 2x. Remember, bringing your negative 3 this way, it becomes positive 3. So you have y equals 2x plus 5. Now, what kind of way are you presenting this? Your final answer, you discover that you're presenting it in the slope intercept form, right? Where in this case, your slope here is 2. Can you see it? Y equals mx plus 5. Where c here is your intercept. So in this case, you can use it to always get your equation of gradients, you can see mx plus c. Your m here is representing 2, your x, and your c, 5. So in case you just ask, okay, what's the intercept? You can quickly get it from the equation given to you. Let's look at the second equation. Find the equation of a line with slope 3 and intercept 2. In this case, you're just simply substituting it in the slope intercept formula. So you have to know all this formula, right? I gave you the 4 of them: the slope intercept form, the point slope, the general form, and where you have that from the origin. Now, we asked to determine the equation of a line passing through the points -2, 3 and 4, 2. Now, in this case, you want to observe that your slope was not given to you directly. What do? You have to find your slope first, which is m, so that you can now impute it in your point slope form to get the equation of the line. Now, first thing you want to do is to find your gradient, since you have your point x1, y1, and x2, y2 is given to you. So you find your gradient, label your point, always label your point. So doing that, you have your gradient to be -1/6. So substituting that here, your y minus y1 equals m, which is your -1/6 already, into x minus x1, right? So what you want to do is you substitute them carefully. So you have y minus 3 equals your -1/6, which is your m, and x minus your x1, which is -2. You substitute them carefully. So opening your bracket and multiplying through by the LCM, which is 6. You get 6 into y minus 3 equals 6 goes with 6. That 6 cancels out 6. You're left with a linear equation now. Opening your bracket, 6 times y gives you 6y minus 18 equals -x minus 2. So collecting like terms and representing it in the slope intercept form, you discover that y is equal to -1/6x plus 8/3. Now, same way, y is equal to mx plus c. So I'm saying this so you compare with your equations and know when to get the intercept. Sometimes you don't need to solve for intercept. You can see your intercept from the equation given to you, and so on. Now let's move forward to the equation of a line with x and y intercept. Now, provided you have a graph, now let's go back to our graphical work here. If you look at this line carefully, we only cut at the y-axis, but in some cases we have a line such that it cuts both the y-axis, something like this. It cuts both the y-axis and that of the x-axis. So in this case, we have a formula for it. So we have such that a line with x and y intercept is represented to be x/a plus y/b equals 1, where a is the intercept in that of the x-axis and b that of the y-axis. So we have a very short and simple question here. You might want to pause the video to try this out also. Find the equation of a line with x-intercept to be 2 and the y-intercept to be 3. Simply substituting, you have x/2 plus y/3 equals 1, provided your LCM is 6. So all you have to do is multiply through the LCM. 6 goes in 2 3 times, 6 goes in 3 2 times, and 6 multiplied by 1, you get 6. Rearranging your equation, you have your final equation to be 3x plus 2y equals 6. You can also arrange this to be in the slope intercept form, making y your subject formula. In this case, you just have to arrange and collect like terms, but we are leaving it this way. Now, understanding this concept builds your knowledge on straight line and answering questions from whatsoever angle they have been brought from. Now, let's talk about polar and Cartesian coordinates. Polar coordinate is simply a way of representing values such that you have their magnitude and the angle between them. While Cartesian coordinate, also known as a rectangular coordinate, is simply a way of representing points in a plane where x represents that of the horizontal axis and y represents that of the vertical axis. Now, your polar coordinate is always seen as r, theta. Just like I said, your r, which represents the magnitude, while your theta represents the angle between them from the positive x-axis. Now, your theta can be in radians or in degrees. If you have a value in radians and you want to convert it into degrees, all you have to do is you have a value in radians. Let's say you have 2 pi and you intend converting it to in degrees. All you have to do is to multiply by 180 over pi. Cancelling out gives you your angle in degrees. Same way, if you want to convert from degrees to radians, all you have to do is, let's say you have something like 30 degrees here, you are just simply going to multiply by pi over 180 in this case. So cancelling out, you get your value in radians. So these are the two major ways of representing the angle in polar forms. Now, conversion of polar and Cartesian coordinates is a very key and important aspect you want to settle down to learn it. To convert from Cartesian to polar, you use the formula r. Remember, it's represented as r, theta. R is gotten to be the square of the magnitude, the square root of the magnitude of x squared and that of y squared. And your theta, from all we've been saying, is always the tan inverse y over x. Now, converting from polar back to Cartesian, you use your x equals r cos theta, y equals r sin theta. Your cos always represents that of the horizontal axis, while your sine represents that of the vertical axis. So do well to note down these formulas from converting to Cartesian to polar and from polar back to Cartesian. Now let's take some examples here. We have some examples to convert the Cartesian coordinates 3, 4. How do you know it's a Cartesian coordinate? You know it's a Cartesian coordinate because it's always come in x, y. So you can see that the x component is presented to be 3 and the y component is presented to be 4. So what do you want to do to convert it to polar? And you already have an idea of how a polar equation, a polar form looks like, just r, theta. So you're looking for your r, then comma your theta. So how do we get r? Simply the square of x squared plus y squared, x3, y4. Substituting, you have your r to be 5 and theta to be tan inverse of y over x. Your y here is 4, your x is 3. So doing that, you get shift tan 4 over 3 to give you 53.1 degrees. We also have another example to convert from polar coordinate 2, 60 degrees. You can see how do you know it's polar? R is 2, theta is 60 to Cartesian coordinate. How do we get Cartesian coordinate? Cartesian coordinates are represented to be x, y, x representing the horizontal, y representing the vertical, and x is always in cos, right? So you have x equals r cos theta, y equals r sin theta. So doing this respectively and substituting your values, 2 cos 60, 2 sin 60, simply giving you your values to give you your x and your y component respectively to be 1, 1.7. Now you also have an example here. You might want to try this last example. Given the coordinates minus 3, 3, find the polar form. So suppose you're not asked to find anything. Minus 3, 3. Is it in polar form or rectangular form? Obviously, it's in rectangular, or it's also known as Cartesian coordinates, right? Because it doesn't have an angle here. It's just x and the y component. So to convert to your polar form, you look for your r component and the theta, which is the angle between them. So substituting r, which is equals to the square root of x squared plus y squared, you have your value to be root 18, which is also root 9 times root 2, giving you 3 root 2. And your value for theta is always tan inverse y over x to give you your value to be minus 1. So minus 1, shift star minus 1 will give you minus 45 degrees. And we're always looking at these values in the positive x-axis. All we have to do is to check the quadrant and observe that minus 45 plus 180 will give us 135 degrees, making our polar form to be in degrees to be 135 degrees. And in radians, how do we convert to radians? To the other time, you have 135. All you have to do is 135 multiplied by pi over 180. We give you 3 pi over 4 in radians. All right, we're going to stop in here for today. I'm sure you've actually learned a lot. So this is actually a series. We're going to be continually dropping more videos like this. This is just the first part of a straight line. We're going to be dropping the second part of a straight line very soon. All you have to do is to like and subscribe to the channel. You also do well to turn on the notification so that when we drop the second part of the straight line and more subsequent videos on basic aspects, science, college courses, and how to ace your exams, you also get notified. Thank you.